Hi everyone, and we're going to continue talking about chemical reactions today, and specifically we're going to talk about the topic of limiting reactants and limiting reagents. I'm Dr. Christy Ruddick, and let's continue talking about reactions. We are actually going to do a little mini lab today. I'm going to do it as a demonstration for you. If you need to, feel free to pause the video as we go along. So here we're going to react aluminum with copper chloride, and the form of aluminum that we're going to use is aluminum foil, so that's why I call it the foil lab. Copper chloride is actually a copper chloride hydrate that we're going to use, and we're going to do this single displacement reaction where we take aluminum solid and we're going to react it with copper chloride in an aqueous solution. So we're going to have this all in water. We're going to form a colorless aluminum chloride and copper solid. And you guys, if you pull a penny out of your pocket, you'll remember that copper is a reddish brown solid, and we're actually going to get the copper out of copper chloride, which is a blue crystalline beautiful compound, and we're going to do a single displacement to get it into the copper solid form. Now we're going to actually focus on the amounts of reactants that we have here. Have you ever thought about what if you don't have the recipe based on the balance equation? What happens? This is your data table that you will need to fill out as you go. If you haven't printed this out, please stop the video and print this data table out. We are going to answer 5 questions and discuss them after we get through doing this chemical reaction. So make sure you have your data table ready to go. I'm going to take the data table in parts. So the first row of your data table says you should fill in where it says number 1. Fill in under the amount of aluminum reacted. We're going to start with 0.16 grams of aluminum, and I have pre-weighed out 0.16 grams of aluminum foil here for us so we can see what happens when we take that mass of aluminum, and we're going to react that with a pre-weighed amount, 2.53 of copper chloride. Now let me get, for my first, I have it labeled because we're going to use the same amount of copper chloride, but we're going to use 0.160 grams of aluminum. Let me take my copper chloride, dump it in there, make sure I get it all out. I'm going to get my stir bar and stir it up and see if you see any physical evidence that copper chloride is in the solution. I picked this because it's easy to see with the naked eye that this reactant, copper chloride, is in the water. So I'm going to stir, 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 try to get it to all dissolve. It will dissolve, and about 50 milliliters of water is what we're using. Okay, once we get that to dissolve, then we're going to take our 0.16 grams of aluminum, and we're just going to dump it in there. Now, something interesting is going to happen, or else I wouldn't be doing this for you. So when I stir this up in the copper chloride solution, we're expecting a chemical reaction, and we get one. I don't know if you can hear the fizziness, but there are bubbles forming, there's steam coming out, and you can see the copper solid is forming at the surface of the aluminum foil, and a reaction is happening. So we can actually see physical evidence that there's copper chloride still in there, it's staying blue. The aluminum is disappearing, and we're forming some copper solid, which you can see as the red solid there. Now we need to let this go for about a few minutes, but just like chefs do on TV, I pre-did one so we don't have to wait a long time. I'm going to put this one aside. This is the exact same thing. I just waited a little while and let it settle. So notice in the end we're left with a blue solution still, indicating that there's copper chloride still in the solution, but there is no aluminum left over. So we don't see any. It all reacted, And there's copper that has settled to the bottom, copper solid that has settled to the bottom of the reaction. Now, to be able to talk about this, we need to be able to do a little bit of math. The 2 and the 3 in the balanced equation are actually mole ratios, so we need 2 moles of aluminum for every 3 moles of copper chloride. So let's take our grams and convert those to moles. For aluminum, we divide by 27 to get 0.00593. For our amount of copper chloride, we divide by the molar mass of the compound we use, which is actually a hydrate, which is 171 grams per mole. We had previous lesson on this. If you're not sure where I got those, go back and look on the video for molar mass. So that moles of copper chloride is 0.0148 versus the moles of aluminum, which is only 0.00593. If we take the ratio of those by dividing the smaller one into the bigger one, we get 1 to 2.50 is what we actually have in this cup. If you don't like decimals, you can multiply them both by 2 to get 2 to 5. So we have, for every 2 moles of aluminum, 5 moles of copper chloride. Now keep in mind that the balanced equation says that we need only 3 moles of copper chloride for 2 moles of aluminum. So make sure you get this written down in your data table. All the aluminum reacted, so it's all gone. Red copper solid formed, and a blue solution remained. Next, we will move on to our second reaction. In our second reaction, we're going to have the same amount of water, and we're going to have the same amount of copper chloride, 2.53 grams, same amount. Make sure we get it all out. I'm going to get my stir bar. I'm going to stir it up. Again, same blue solution as we had before. Stir, 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 stir. Okay, now we're going to add in 0.267 grams of aluminum into this solution. Dump. And we should have, now notice that's a larger amount, 0.267 in the second beaker, in the second reaction. In the first reaction, we only had 0.160. Okay, so we might see something different happening. It's fizzing, it's getting hotter, it's fizzing a little harder. Okay, notice that the copper solid is forming on the aluminum again. And we will stir, 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 and see what happens after about 15 minutes. So again, I did this one ahead of time, so let me get my magical result after about 15 minutes with 0.267 grams of aluminum and 2.53 grams of copper chloride. This is our result. When we do our mole conversions, in this case we get 0.00989, slightly larger number of moles of aluminum, and we get 0.0148, a slightly larger number of moles of, the exact same moles of copper chloride. When we do the ratio for this one, by dividing 0.00989 into both numbers, we get 1 to 1.5. Or if we get rid of the decimal, that is a 2 to 3 mole ratio. Now keep in mind, that's what our recipe says we need. So what are our observations and what does that mean? So notice there's no more aluminum left in here. A lot of red copper formed at the bottom, and there's no blue color remaining. So to me, I can't see any aluminum left over, and I can't see any blue copper left over. So let's think about what that means after we get finished with this little lab. Let's do the third one now. I'm going to put that one aside. In the third one, you probably guessed, I'm going to use even more aluminum. This time I'm going to use 0.66. I'm going to use the exact same amounts of copper chloride, which is 2.53. Same number of mass, same number of moles for copper chloride, larger amount of aluminum. So if I get my stir bar, stir it up, get my nice blue solution of copper chloride, get it ready. Now I'm going to dump in a very large amount of aluminum, 0.666 grams, and see what happens. You probably have an idea. You might already be predicting what's going to happen. So I'm going to stir, stir, stir here. Okay, same thing's happening. Sizzle, bubbles. It's starting to form copper solid. Stir, stir, stir. Okay, keep stirring. Can you predict what's going to happen? You notice the color is changing. The solution is losing its blue color. Lots and lots of copper is forming at the surface. It's getting very, very hot. Okay, so exothermic reaction, we already talked about those terms. So I'm going to stir, 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 and let's see. After this gets done, here's what it looks like. This is the 0.66. So notice it is a nice, clear, colorless solution. There is copper solid formed and lots of aluminum left over. So we have lots of aluminum left over. I don't see any blue color, so let's fill in our data table. For our moles of aluminum, we have a larger number of moles, 0.0247. Same amount of copper chloride, 0.0148. So our mole ratio this time is 1 to 0.599, or 2 to 1.2. So in this case, now remember, we need 3 moles of copper chloride for every 2 moles of aluminum. So we only have 1.2 for every 2. Our observations, some of the aluminum disappeared, but a lot of it still left. All the blue color disappeared. We're left with a red copper solid in a clear solution. Now, let's think and discuss. Make sure you get all of that filled out before we move on. If you need to go back and fill it out, feel free. Now, I'm back. I have your entire data table in front of me here. So, what I want you to do is try to look at this data and think about what happened and make some explanations. So, based on your observations, in which reaction was aluminum all used up? I want you to explain and cite evidence from your observations. Go ahead and pause me and think about that and write an answer to this question on your handout. Then unpause me and we'll discuss it. Okay, so in which ones was aluminum all used up? We can just look at our observations. All of the aluminum reacted in numbers 1 and number 2. So number 1 and number 2, no aluminum left over, right? How do we know? We don't see any. That's all we wanted to say. Very simple. Okay, next question is, based on your observation, in which reactant was copper chloride dihydrate all used up? Now remember, it was blue, so which one had no blue left over in the end? Okay, if you look at your observations, you'll see it was number 2 and number 3. The copper chloride blue solution was completely gone. In this case, there's nothing but product, and in this case, there's aluminum left over, but there's no blue copper chloride. So that's 2 and 3. Question 3. Which reaction used up both reactants completely? Pause me, think about it, write down your answer, and then come back. Okay, if you said 2, you're correct. So there's no blue and there's no aluminum, so everything was used up. So let's think about that for a second then. It was the only reaction where we had the right recipe from the balanced equation. 2 moles of aluminum for 3 moles of copper. And all the aluminum got used up and all the copper got used up to make only product. There was no leftover aluminum. There was no leftover copper. We had exactly what we needed. Okay, so there's that. Now, we're going to discuss these 2 questions. I want you to pause. I want you to think about them. I want you to write your answers and then come back. Okay, So limiting reactants are the reactants that are used up completely. What's the limiting reactant for each beaker? So we go back to beaker 1. The aluminum was completely used up. So limiting reactant is aluminum for number 1. Double check your answers. For number 2, there's no aluminum, but there's also no copper chloride. There's no blue and there's no aluminum foil. So I don't know what to say. Looks like there are 2 limiting reactants. Go back to the third one, and the copper chloride's all used up. So the copper chloride's your limiting reactant, and we have aluminum left over. Now, for question 5, excess reactants are the reactants that are present in higher quantities than required by the mole ratio in the chemical equation. There is always excess reactant left over when the limiting reactant is used up. What is the excess reactant for each beaker? Pause me, think about it, answer, and then come back. If we go back to number 1, can you see anything left over? That's right, blue. So copper chloride is the excess reactant. We already said aluminum was the limiting reactant. In the second reaction, everything was used up. So is there any excess blue? No. Is there any excess aluminum? So it doesn't look like there's an excess reactant. And this is a special case because we already said we had exactly what we needed. We have no extra left over. We have no limiting reagent, no excess reagent. We have exactly the right amount from the balanced equation. In the last one, the excess was obviously the aluminum, so that's left over and all the copper chloride is gone. So what does this mean? I already told you that reactions are like recipes. So let's say you're going to go and you're going to make a sandwich. And you're going to make sandwiches for your friends. And you look in the refrigerator and you see that you have 3 pieces of bologna. Granted, they're going to be boring sandwiches. And you just assume that with those 3 pieces of bologna, you're going to make 3 sandwiches. And you don't check on the bread. And then you realize your mom didn't go to the store. And you know you're going to need 6 pieces of bread, but you only have 5. Are you going to make 3 sandwiches? No, you're not going to make 3 sandwiches. Because you can't base how much product you're going to make on an excess reactant. You have to base it on the limiting reactant. Now, how many would you need? You would need 6 pieces of bread. So if you have 6 pieces of bread and 3 pieces of bologna, then you're going to make exactly 3 sandwiches with nothing left over. And this is the case where you have exactly what you need. Now, if you need to rewind this, you can rewind this, but that is our lesson on limiting reactants, and we'll follow up with this in the next lesson. Thank you for joining us.